Okay. Hello, I'm Paul Magnus. This semester I was working on a language that I've come to call PyShell. So what I wanted to do was improve shell scripting by using Python, which we're all familiar with, and so hopefully will make any kind of script you want to write a bit easier. So first off, what are some things we like about current shell scripting? Well, it's really easy to call commands. We can just write the name and give the arguments with a space afterward. We can also interact with files very easily, both for input and output. These are things that in traditional languages like Python are a little more complicated than we might like in scripting. Pipes are especially nice. This was actually a feature that was originally created for Unix scripting. And if you're not familiar with it, it takes the output of one command, ls, and sends it as the input to the next command, grep, which will then filter so that you only get the lines that contain py. And then we can also combine these in all sorts of ways to get different useful combinations. So, well, that's all well and good when you're writing small scripts. But when you start writing these larger scripts, which on our server, we have about 10,000 scripts. And on average, there are about 360 lines per script. So there are a good number of these larger scripts. And what you'll find in most of them is that you're really not doing a lot of stuff that Bash is great at. You're doing stuff that you'd love to do in a language like Python, like you're doing integer arithmetic. You're doing floating point arithmetic, which really gets ugly because you have to send it off to another program. Or maybe you want to sort an array. And not only do I have to call an external program sort, I have to send in as a here file and change the internal field separator and then reset that so that I won't mess with anything else. It would be so much nicer if we could just write these in Python. So that's what we do. So you'll see over on the left, I have my a very simple PyShell program, and a lot of that is just Python that you're used to. But the highlighted parts are this new syntax. So we use $signs in this language to identify our scripts. This is because Python doesn't use anywhere else, and especially as your scripts get longer, it's not that much more to add on. We can do commands just the way you would expect in Bash. Quoting comes in since we're separating our arguments with spaces. Unlike Bash, we treat both kinds of quotes the same way, just like Python. And we're actually going to treat all of these commands and arguments just as regular Python strings. And so if we're treating them that way, we can actually, we might want to send in variables that are these strings. And so because we've already said we want to make commands and arguments as simple as possible, we need to identify what a variable is. And so within this language, we use an @ sign for that. This allows for some pre-computed results that you might want to use. You can also do loops, as I've shown, running multiple commands in sequence. Now, when I started this project, one of the things that I didn't like about Bash was the fact that they had the $sign before variables. And But what you have to think about is what happens if we say we want bare variables. So this first case, LSR. Well, that means if I want to pass a regular argument, you need to quote it or some other identifier to differentiate from variable. At which point, especially if you want this second example to work, well, then we need to do the same kind of thing for our commands. And now our very simple ls-al has become really annoying to write. I found as I was using these variables that a lot of the time when I wanted to write them, I would end up having things like the first example up there, where I would set a variable from a function and then immediately use it within the shell and never use it again, which I generally try to avoid doing that if it's not too complicated in Python. And so what I did was I added just a way to embed a basic Python expression. These, if you're familiar with functional programming, these should tend to be functions that you could find in a functional programming language, trying to minimize the side effects and have just a result come out of this. Just because, at least in the current implementation of some of the back-end things that have to happen, you can get some weird side effects. So far, all we've done is worked with simple commands. But we said we also like file, input and output. So maybe I want to count lines in a file. Well, we keep this arrow syntax from Bash as our input to commands. And we can even throw in variables there. So if you have a string there, we're going to take that as your file name. But if instead you actually give the script a file object, which so it has a read operation, then it will instead just read from that object directly. We can do a similar thing on output, as long you can send a string for the file name or a actual writable file object. Now, at this point, all we've worked with is our standard in and our standard out. But there's actually a third output, your standard error. It's not used quite as often, but it's still useful. And languages like Bash generally number these 0, 1, 2. And so if you've ever seen a statement like command 2, arrow 1, that's really what they're doing. They're changing around where these are going. And so I wasn't really a fan of that. I felt like the numbering system didn't really make much sense. It just kind of made it confusing. So instead, I define 3 more output operators. So the exclamation point I have for an error. So you're sending the error from find to file, which we can represent in a graph like this. The errors are always coming out the bottom. Then we can also join. So and we want standard out and standard error. And so that results in both of them going to our file. Now, this last one, doing a split output, where you want the standard out to go to one place and the standard error go to another place, is actually really annoying to do in Bash. You have to create other file descriptors that are going to be there temporarily so that you can move things around. So instead, I thought, why does it have to be any more complicated than just, I send out to these 2 different places? So we implemented that. Pipelines, I did basically the exact same syntax. You can see going from one command to the next. with your regular pipe, error, join, and split pipes all working there. Now, with Python, we were able to add a feature that isn't really present in a regular bash shell, because bash shells are at first intended for just running on the command line. So you write a line of code, it runs. Since we're expecting these to be written in files, we didn't have as much of a restriction on this. So rather than writing ls grep py in one line, we might want to split this up. And so we could label this pipe as p. And if we do that, we could say, okay, ls is going to go to p. This is a variable that hasn't been used before. And so it's going to create this automatically and link it up. And then at some later point, we can decide p is going to be the input to grep. At that point, now that we've linked up both ends, we then simplify it to a pipe. And now that there's nothing else on here, it executes. And also, p is now set to a kind of default state so that we can use it as another pipe if we would like later. So this actually allows us to do some generalized code here. We can write things like our function foo that's going to create the first part of our pipe. And here it's a relatively simple example, but we could have a much more complicated script in here and just have some trailing pipe here that we then can call in bar and link up with two separate outputs. These once again get reduced and executed as you would expect. This is one feature that I have wanted, but is still in development. It's a bit buggy, but if you'll notice, the join pipe is a little different from the other kinds of pipes because you've got these two streams coming together, which doesn't happen anywhere else. And so the idea with this joining of broken pipes is to do this in an arbitrary way. You have two broken pipes, I'd like them both to go to the same place. And so we create our two pipes, and then we use an ampersand to say I'd like both of these as input. And with the addition of this, we can actually now create an arbitrary directed acyclic graph of these commands being piped from one to the next. So moving to a little different part, one of the things we like to do a lot in Bash is use commands as things like iterators. So maybe I'd like to go through all of the files in my folder. So I could do that with for-f in ls. Or I could directly get that list by just asking for the iterator. Similarly, if I want the return code, I could throw it in if statement, and it will check the return code, or I could use bool or int, depending on my need. One interesting result that we got after a lot of this had been built up that we realized we could do is we could build things that were either impossible to build in Bash or very hard to do. Things like an arbitrarily long sequence of pipes. So here we start with ls being sent to p. This creates this pipe. And then on our first time through the loop, that gets linked in to grep.pysh. And note that now that we've simplified it, P is now available again as a variable to be linked up. So now P is this link. And we go along as many times as we loop through this, and we can get a sequence of these pipes, one into the next. You can also do this recursively with functions by returning and sending pipes and similar kinds of things to that. So in conclusion, we had this annoying bash script that was mostly stuff I'd like to do in Python. And so in the end, we've actually converted this over to PyShell. And those 3 lines highlighted in orange are the only ones that actually required use of our new shell script. So most of the stuff you write in this language is probably Python that you already know. And we only need to dip into this when you absolutely decide you need to use the shell. So some future places to go. Of course, there's finishing up the join pipe, as I was mentioning. Some stability improvements, as with any program. Every time I run more tests, there's more edge cases that seem to not quite work correctly. So before this gets actually used much more, it will need some improvements on that end. I put parallelization up here because in reading some literature on different shell scripting research that's going on now, there's a lot of focus on taking things like Bash and being able to run it on multi-core CPUs in order to speed up larger script programs. And so that definitely, to me, seems like a direction that this project could go in if it's ever going to gain more traction in the modern programming environment. I would like to thank Professor Bailey for advising me this semester and the whole department for guiding me these 4 years.